So we're going to talk a little bit about arithmetic and geometric sequences. You should have at this point at least been introduced to both. The idea is arithmetic, you're adding every time to get to the next term. Geometric, you're multiplying. So if you notice on this first one, we're adding 6 every time to get to the next term. So if this pattern continues. And so to get the next term here, we'd say 27 plus 6, 33. Plus 6 is 39. Plus 6 is 45, and the same thing will continue going. Plus 6 is 51. You could do this forever. A geometric sequence, on the other hand, we're multiplying every time. So notice here we have times 2, times 2, times 2 to get to the next term. So when this pattern continues, 32 times 2, 64, times 2, 128, times 2, 256. Geometric sequences and arithmetic sequences can also be represented in other ways. Here's one way that geometrics are represented. So we're given that bacteria triples per year, and we know in general that an equation of a geometric comes in this form. The A being the number with the starting, so at the 0 slot for x, the B being how much it changes per year. So the fact that it's per year, it triples, we have a 3 there. So to go from 2 to 6, it times by 3. It's a geometric sequence. To go from the 6 to the next whole number, it would times by 3. So we know this slot is 18. And if we wanted the 3, like the 3 for the x value, the next one, we would times this by 3 again. Another way, if we want to get these middle ones that may be harder to see, is to use this equation. So in our calculator, we'd say 2 times 3 to the, now we're going to put in our power. So what I would recommend doing is putting this in parentheses just so our calculator reads it as together. And we get 3.46. So notice it's slightly not halfway between because it's not adding every time, it's multiplying. So here for the 1/2 power, we get 3.46. Here's a cool trick. If you go second, enter down here at the bottom, it pulls back up the last equation you used. So if we want to put in the 3/2 now, all we have to do is slide over, put in a 3, and click enter again. So now putting in 3/2 in for x, we'd end up with 10.39 for our bacteria. So 10.39. If we want to put on 5/2, same trick, second, enter, up again, put in a 5, and we get 31.18 if we round up. 31.18. So you can see that at a certain point, this thing starts growing really, really fast. And the bigger the numbers get, the more that increases. The rate at which it will increase gets faster and faster. The numbers get big fast. That's one thing about geometric. So bacteria grows by a factor of 5 times per year. So here's our A, here's our B. That's the factor. So what we would do is say y equals 2 times 5 to the x power. We don't have the next whole number 2. Let's just say we did. If we had 2 here as our next number and we were trying to find the slot that goes with it, we would say 10 times 5 gives us 50. And our next whole number 3 would be 50 times 5 or 250. To get our middle ones, we're going to put in our calculator again. So 2 times 5 to the, 2 times 5 to the. In this case, we're putting in thirds. So 3.42 is our first one. Put in 2/3. 5.85. Put in 4/3. Oh. There we go. 17.10 if we round, and put in 5/3 and get 29.24. So rather than type it in every time, second enter is a quick way to put it into the calculator. And we can fill in the missing terms of this geometric sequence. The geometrics happen at the whole numbers, and that's what gives us a sequence just like up here. These would be slot 1, slot 2, slot 3, slot 1, slot 2, and we could keep going.